So today we're going to be solving problems involving quadratics. This will be the last lesson on quadratics for the year. So it's taking all of the different tools that we've picked up over all the different cycles and putting it all together and yeah, just it's a good summary lesson, I guess. Okay. All right. So I'm just going to go over an example here, and we're just going to go step by step and finding the different properties of this quadratic. Okay. All right. So again, we have our equation here, and it's in standard form. Okay. So standard form is always, it doesn't have brackets, and it always, it has like the x squared, the x, and the constant. Sometimes some of the parts are missing, but in general, this is the form. The key is that it has no brackets on it, okay? So that's how you can identify easily. So now that you know the standard form, can you tell me, whether it has a max or a min, okay? So give ourselves some space here. So does it have a max or a min? Okay, so how do we know that if we don't graph it on Desmos, or how do we know if it has a max or min? So again, just to review what max and min are. So in general, if you have, I don't know, like a quadratic that does this, okay? So it keeps going down. It keeps going down forever, but this is the highest it got, okay? Then there's this one here where it's the opposite. It keeps going up, 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 up. Whoops. But this is as low as it gets here. Okay, so this one here has a maximum. Okay, because we can at least actually read off a value for the maximum, where the minimum we can't find the bottom of it. It goes on forever. Okay, this one here we can say it has a minimum because, again, same thing, we can find the bottom of it. We can determine how low it went, but we cannot find the top of it. So we're trying to figure out with this first example here, does it have a max or a min, and how do we know? So even though, again, we didn't graph it, is there a way to predict which way it opens? Okay. All right. So if you're kind of trying to brainstorm and trying to remember, it has something to do with this first number here. Okay. All right, so hopefully you've had enough time to think about it. So if this number here, right, it's like A, positive 4, right? So anytime it's positive, it opens up. Okay, so it'll look something like this. Okay, so if we know that it's opening up because, there's no negative here, it's a positive number, it opens up. So is this a max or a min? Okay, so you can find the bottom of it. So yes, this quadratic here that we're studying has a minimum. Okay, how do we know that? Because the a value is positive and it opens up. Okay, so you can kind of write that now. So again, because of the a value here was positive, we know that it opens up and therefore it has a minimum. All right, so let's go to the next one here. So we are looking at what are the zeros of this relationship, okay? So let's write the equation out. And zeros, that's what we did last day. How do we find the zeros of a quadratic that looks like this? Okay, so I know we practiced putting it into Desmos, and then we can read off the x-intercepts. Okay, so just a reminder, zeros is the same as x-intercept. So that's what we did. We can, take a graph and look at it and find the x-intercepts if they're nice. But also algebraically, we practiced factoring, so we can do that as well. So, go through the steps of factoring. So look for a greatest common factor. So I'm checking, let's see, 4 is the smallest one of all 3 of those numbers. So can 4 divide out of 72? Yes. And 260? Yes, it can divide out of both. So that's the common factor. They don't all have an x, so we don't need to take out an x. Okay, so go through and write out the factored form. Okay, so write the greatest common factor there. This becomes x squared. This becomes 18. 260 divided by 4 becomes positive 65. Okay, all right, so we got it partially factored out now. So the next step from our this week lessons are, oh yeah, so that means this one here is the one we have to figure out is being added to that and multiplied to this. Okay, so let's just do our table here. Add to 18, multiply to 65. All right, so think of all the factors that make 65. 1 and 65. Nope, that won't work. 65 divided by 2. No, it's a decimal. 65 divided by 3. Nope. 65 divided by 4. Nope. 5. Okay, 5 works. So 5 and 13. So again, you're looking at your factors table from the other day and just thinking all the numbers. All right, these two could be tweaked to add up to 18, but we need negative 18. So the other possibility is to make them both negative. Okay, so that you still get a positive 65. But then you add to negative 18. Okay, so those work. All right, so we found our factors. So let's write them in. Okay, so yeah, so both of them are negative. Good. Okay, so then the question asks for the zeros. So this is what we did last day. We just popped out, once we got to the factors, we popped out the opposite sign. So the number with the opposite sign. Okay, so positive 5, positive 13. Okay, so so from there, we need to figure out the max, the x-coordinate of the max and min. Okay, so far what we know is that we know that it opens up. So if we make a sketch here, so we know that it opens up. Okay, and then in the previous question, we just found that the x-intercepts, if you were to just make a rough sketch here, are 5 and 13. Okay, and so right now we're trying to figure out, okay, so you know that this is the minimum point right there. So we're trying to figure out the x value of it. So here it's a point, right? We're trying to find the x. So think of this is remember these are the x-intercepts, right? So if we're looking at where this minimum point is, so you know it's the vertex, right? So you have been studying from the beginning of the year that there is a line that actually goes through it called the Axis of Symmetry. Okay, so it cuts it right in half. So whatever the x value is here, that's what the x value of the vertex is. So we need to figure out what is halfway between 5 and 13. Okay, so if we're looking at this again with all that stuff in front of you, 5 to 13, what's halfway here? Okay, that's what we have to figure out. All right, so if I just write, okay, x, what this number is going to be, it's halfway. So to find halfway, it's like averaging it, we're going to add the two numbers and divide by 2. That's how you find the midpoint, halfway. So 15 plus 5 plus 13 is 18. And you divide by 2 is 9, okay? So the x value, okay, that's right here is 9, okay? And so that's the x value of the minimum or the vertex, okay? So, or you can call it x coordinate. Okay, so therefore the x coordinate of the minimum point is 9. Okay, all right, so so that's something new, but again, it's kind of what you've covered before with the whole vertex and then the axis of symmetry. So now that you know the idea of what zeros are, it's always halfway. That's how you find the x coordinate of the minimum or the maximum point, okay? Halfway between the zeros, so 9. Okay, from there now, we have to figure out, well, so if we know, that it's a minimum and we know that, I want you to find the max or min. So basically you did this in the past before. So if you had like, so for example, if you have our graph here, you know there's a minimum. You know that, you know, it hit at 5 and 13 like that. So you know that this point at the bottom is the minimum point, right there. So I want to know, how low did it get? Okay, so we've done this before. It's whenever I've asked you for the optimal value. So again, we don't have a graph. We always had a graph and we were able to read it off and find the min point. But now I want you to actually calculate it out. Okay, so how you're going to do that is you were given an equation right at the beginning here. Okay, so you're going to take that equation and then just have it written out here. So it's y equals 4x squared negative 72x, oops, plus 260. Okay, so going back, our original question. All right, so here's the equation. So far, like all of these questions are all connected together. So if so far in the previous one, we found the x coordinate. So if we have the x and y here, we found the x coordinate to be 9. Okay, so we don't know how low it went. So that's what this is the y value here. Okay, we need to figure out how low this quadratic went. So now that we know that x is equal to 9, we can plug it right into this equation here and calculate out the y that matches. Okay, so let's do that right now. So I'm going to, so again, x equals 9. I'm going to plug that into all the x's here. Okay, so here I'll use a different color here. So this will become 9. And then you need to square it. And then you go subtract 72, but then again, you're going to replace the x with 9. And then you're going to add the 260. There you go. Okay, so go through, follow BEDMAS. So I'm going to take care of this exponent first, 81, like that. Okay, so now I'm going to go through and multiply. Okay, 81 times 4 is 324. The next one, 72 times 9 is 648, and then plus the 260. All right, so now that we've taken care of the multiplication, I could just add these together. 324 subtract 648 plus 260. Okay, so we have a value of 64. Okay, so yeah, it makes sense that it should be in the negatives. So the maximum, or no, it's the minimum, sorry, the minimum is 64, or negative 64. Okay, like that. All right, so again, something you've already found before in the past, but using a graph now, you're going to use the equation, okay? All right, and then again, to find the x value, just take halfway between the zeros that you found in B, and then yeah, so you should know which way it opens, up or down, okay? All right, and the last one. Now we have to write it in vertex form. So again, coming back to reviewing stuff from before. So the vertex form looks like this. Okay, so this was the first form that I guess we analyzed when we started to look at the quadratics. So just a reminder, whenever you looked at this form, the vertex is right there. Okay, so the vertex was HK, like that. Okay, and A is, you know, like the A that we already found up here. Okay, so back here, we found A. A was 4. It's that number that's right in front, because the standard form, if you look at the general form, it is like this. It's ax squared plus bx plus c. So it's the A is the same for both of these forms. Oops, so, okay, we know A. A is 4. Okay, so from there, we just need to figure out the vertex. But what is the vertex? That is this min value here. Okay, so we found that the min value was, well, the x coordinate was from this part here. We found it was 9. And then in part D, we figured out how low it went. It was negative 64. Okay, so once you know your vertex, this is also your vertex, okay, the min value or vertex, you're going to just plug them right into your equation. So y stays the same, equals stays the same. A becomes 4, bracket, x stays the same, subtract. Now let's put the h in. H is 9, like that, squared, and then k is negative 64. So write negative 64, like that. Okay, and once you get everything filled in, clean up any signs, make sure there's no double signs, then you're good, and that's the vertex form. Okay, here's the next example here. So we have a new equation here, but the same questions being asked, okay? So I want you to go through and, yeah, make a decision on whether you think there's a maximum or minimum for this graph here without graphing it, okay? So you can kind of go through all these steps and then check the graph using Desmos. So again, I'm looking at the A value here, and we're trying to determine if it opens up or down, and then determine if it has a maximum or a minimum here. Okay, so here is the equation, and again, we're looking at the A value here, and you can see that it's a negative 2. So it's a negative. So that means it opens down. Okay, so just do a rough sketch of that. So if it opens down, this is what it looks like. So does that have a max or min? Okay, so again, you can see the top here, you can measure it, so that's the maximum. Okay, and like if it, with the arrows here, it goes down forever, so you can't ever find the bottom, so you don't have a minimum. Okay, so you know that it is a maximum. And the reason why, you know, because it opens down. Or if you wanted to write the A value is negative, that's totally fine as well. Okay, all right, so let's move on to the next one. I want you to find the zeros. So again, hopefully when you see something in standard form, which it is right here, you need to get it, so that's standard form, you need to get it to factored form. Okay, all right, so if you get it to factored form, you'll be able to determine the zeros a lot easier. Okay, so let's do that. I'll write it out again here. Okay, so step 1, always look for a greatest common factor here. So again, take the smallest number, 2, and then because it's negative, let's get that negative out of there too, and then double check, yes, I can divide 2 out of all of these. So you're going to go through and divide the negative 2 out. Okay, so let's write the negative 2. Now we'll cancel these out, and then you get x squared, cancel this out, get just negative 5, and then divide that in by 2, and you get 66, okay, like that. All right, and then we want to get it to the factored form. We're not quite there yet. We got it slightly factored out. So you need to build your add and multiply table. Okay, so this one here, that's the one we need to add to. This is the one we need to multiply to. So let's build that. So negative 5 here, and then we have negative 66 here. All right, so from there, we need to decide, okay, so 1 times 66. No, that can't be tweaked to make 5. So what about 62? So our 66, so can be divided by 2. So 2 and 33 can make 66, but not 5. All right, let's try divided by 3. So 3 times 22, no. 66 divided by 4, nope. 66 divided by 5, nope. So again, you're just looking at your factors table. All right, I just found this one. Okay, 6 times 11 makes 66. Okay, but here we have to make it negative 66. So here are the options. One of them has to be negative. Okay, and if you want to use that trick of see if you have to get to negative 5, pick the one where the bigger number is negative, right? Because, yeah, when they go in battle, the negatives will win and make a -5. All right, so these are the two numbers. So let's factor this quadratic out. And this is like, we factored a little bit, but we always want to factor as far as we can. So this is factoring as far as possible when we write out these ones here. Okay, so we get the +6 and the -11. All right, but again, our goal here is to find the zeros, which if you were to graph it, it represents the x-intercepts. Okay, so what we're going to do is we look at the two factors that we just found. Again, this -2 doesn't affect the intercepts. So you're just going to pop out the number, but with the opposite sign. Okay, so -11 becomes positive, +6 becomes -6. Okay, all right, so hopefully those aren't too bad. Let's try the next one. Now you got to find the x-coordinates. So this is the kind of the new part. So again, just make a sketch to help you visualize what you have to find as well. That will be helpful. Okay, so if you are looking at the x-coordinate of the maximum point, so let's just make a rough sketch. We knew that it opened down. Okay, so let's just make a sketch of that. So we know that it opens down. Okay, so we know that we have a maximum. And we just did, we found the zeros in the previous question. So if I don't know, made a rough sketch of that. Okay, so one of the intercepts was at -6. One of the intercepts was at +11. Okay, so that's what we found. So again, here is the max. It's a point, and it's like the vertex. So we want to find the x value for the vertex, the max point, and that max point is located halfway between the zeros. So remember, halfway is where you draw your axis of symmetry, but halfway is where the x-coordinate of your max point will be. So to find halfway, remember, we're just going to add the zeros together like that, and then we divide by 2. Okay, so -6, 11 will battle, positives will win by 5. Okay, and yes, this one happens to be one that's not as nice, but that's okay. We can get an x value that's a decimal sometimes. Okay, so from there, yeah, that's all we needed to find. Okay, so that's the x-coordinate. Okay, of our maximum. Okay, all right, so the next part is to find the actual max. Okay, so again, if we make a rough sketch here, so we know this, sorry, it's not to scale, but we know that one hit at +11, this one hit at -6, and then we found about 2.5 is where the max is supposed to be. Sorry, it's not properly drawn here. But so we need to now figure out, okay, well, how high did it go? So what's the max value here? Okay, so we need to figure that out. All right, so in order to do that, so we know x is equal to 2.5 from the previous question. We need the equation. Okay, so back up here, -2x² plus 10x plus 132. Okay, so there's our equation. We know our x value. So now we need to figure out, we just need to calculate it out by subbing it into this equation here. Okay, so write everything else, and then we're going to replace the x's with 2.5. Okay, and then, right, plus times, and then we have 10. We're going to replace the second x here with 2.5. Okay, and then write everything else out. Okay, all right, so follow BEDMAS. Let's do the exponent first. 2.5 times 2.5 makes 6.25. And I know some of you would say, can I just multiply that at the same time? Yes, you could have just multiplied that, but I'm just putting all the multiplications in this next step. All right, negative 2 times 6.25 is negative 12.5. Okay, 10 times 2.5 is 25, and 132 is left. All right, add all those together. Don't forget the negative on the 12.5, and you will get y is 144. Okay, so that value, the value that's right there is the max value. Okay, so just write that. So that's the max value. All right, last one. Write this equation in vertex form. Okay, so here's the vertex form again. All right, so again, we need the 3 letters filled in, H, K, and A. So we know A already from the original equation. Okay, so if we looked back in number 1, A, see how A was 2, negative 2. So that's still the same here. So we're just gonna put that there. Okay, well, we know A is equal to negative 2. All right, we did find the max, right? So what was the max? So the max is at, so the x value was 2.5, and the y value was 144, like that. Okay, so remember, so the max is also the vertex, right? And the vertex in the vertex form are the letters H and K, like that. So we're going to throw them in. And write the numbers instead of the letters. Oops. Okay, so let me write this over again, sorry. So negative 2 is the A. Okay, x subtract 2.5, which is your H, and then plus your K, which is 144. Okay, and here's the third example. We have a mountain biker riding along and then jumping off a ledge, landing on the ground, and we need to find out some information about what's happening with the situation, okay? So we know that, so if we make a sketch here, we know that, so this biker comes along and is up on a ledge somewhere and then jumps down, okay? So, so that's kind of like the rough idea here. So the path that, that they took in order to jump to the ground, okay, here, this path, is modeled by this equation. So h is the height, so this is the height of the, the ledge, or how high she was in the air, and d is the horizontal distance, so how far along the ground she travels. Okay, so she started here, and then when she did her jump, she traveled this far. So that's the horizontal distance. Okay. All right. So in part 1 here, I want to know what is the height of the ledge, which is right here. Okay. So in this scenario here, so right at this point here, how far away, like where is she with respect to the horizontal distance? So we can assume that this is 0, right? This is where she starts, and then she starts moving this way. So d is equal to 0 at this point when she is, like if it's right here, or if we're just trying to measure the height here. So if we know d is 0, this is our equation for the height. Then that means I can plug in 0 for all of the d values here. Okay, so once I do that, this whole thing, when you multiply, if you go 0 squared, it's 0. 0 times this becomes 0. 1.2 times 0 is 0, and so that leaves us with 1.5. Okay, so the height of the ledge is 1.5 meters, okay, from here to here. All right, and then yes, don't forget your therefore statement. All right, so now, how far was the rider from the ledge when she landed? So basically, she jumped and landed here. So how far is that? That's what we need to figure out now, okay? So maybe here, I'll make another diagram. Oops, that's the height. So now we're trying to figure out this distance here, okay? So last time it was from here to here, the ledge height. Now we're trying to figure out how far she landed from the ledge. All right, so again, kind of going with what we did in the previous examples, whenever we found the quadratic, and then we found the point where it's on the x-axis, right? What were these called? They were called the zeros. So you had to find the zeros. So if we can find the zeros here, we can figure out, if we know what number this is, we'll know how far she traveled and landed onto the ground here. Okay, so how do we find zeros? Well, we have this equation here. Actually, we'll start it over here. Okay, so we have something in standard form right now. Okay, lots of decimals, yes, but we have something in standard form. So if we can get from standard form to the factored form, we can figure out the zeros, okay? Because from the factored form, we just pop out the zeros. All right, so let's go through and factor. So as usual, we need a greatest common factor check. So when we do that, again, see how the first one is negative and has 0.3, so that's the one we're just going to take right out. Okay, we don't want that negative there. And then, we don't want a number there. We always want it to just be 1. So it's 1x squared, or in this case, dx squared. So let's take out the negative 0.3 out of everybody here. Okay, and then we're going to write our common factor outside. Okay, no letters had to be divided out because, yeah, the 1.5 didn't have a d. Okay, so when I take 0.3, negative 0.3, and negative 0.3, divide them out, they cancel out, and they'll lose a d squared. If I take 1.2 and divide by 0.3, negative 0.3, I'll get negative 4d. And if I take 1.5 divided by negative 0.3, I'll get negative 5. Okay, so much nicer looking quadratic here that we can factor. Okay, so again, how do we factor once we find the GCF? Remember, we have to figure out what adds to this one, what multiplies to this one. Okay, so let's make a little table here. All right, so what adds to negative 4, but what multiplies to negative 5? That's what we have to determine here. So, so all the numbers that multiply to 5, well, 1 and 5, any others? No, I think these are the only two that work, but yes, I can at least multiply to 5, and I could tweak this to somehow add to 4. So since I need a negative 5, that means one of these has to be negative, one of them's positive, or vice versa. Okay, the 5 is negative, okay? All right, so which one of these will add to make negative 4? And again, like I said, the bigger number will have to have the same sign as the answer here. So see how negative 5, if I add that, I'll get negative 4. So that's the combination or the pair that you need. Okay, so right from here, let's keep factoring this out. Remember, we factored a little bit. We want to factor as full as we can. So we have a +1 and a negative 5. Okay, and then from there, to find the zeros, okay, we don't worry about this negative and this 0.3. We just look at the factors right here in the brackets, and we pop out the opposite sign. +5 and -1. Okay, so these are the zeros. So again, now if we make a rough sketch here, so there's -1 and here's +5. So again, she did this, right? There's this part here that doesn't make sense because that's inside the ledge, I guess, but this part here, she jumped and she landed here. Okay, so this one's not an answer. So you would say, oh, from here to here, that's 5 meters. Okay, right in here. So the question was, how far was the rider from the ledge when she landed? Okay, so you can say, therefore, she was 5 meters away. Okay, all right, so I just wanted to show you one example where it's actually applying to something. Just let me know if you want to see some more problems, and I can, put up some more videos and so forth. But in general, now when you have a quadratic equation, that you know how to go through and, like find things like where's the vertex, where's the max and min. So like here, if I let's make a rough sketch here. So here's a quadratic. The vertex is here. Okay, the vertex we also call, in this case, a maximum. Okay, so if it ever says find the maximum height, find the highest point, then we know we need to find the vertex. Okay, if it ever says where did it land, okay, where did it land and stuff like that, that's the zeros or the x-intercepts. Okay, so just kind of make those connections with these word problems. So that like when they use a different type of terminology, you still know what you're supposed to be looking for. Like I need to factor this out and find the zeros, and then I can figure out where they landed and so forth. Okay, I'm going to give you some examples where a ball's being thrown, someone's jumping over something. So same thing, I'll ask for a maximum, so it just means go find the vertex. I'll say, okay, where did they land? Then that means go find the zeros, find the x-intercepts, and so forth, okay? If there's other scenarios too where it might go this way. Most of them are like this, where we're just launching something. But if you were to do, one like this, it might be that it's a bridge. And so you need to find, again, the vertex, but they'll say find the lowest point. Okay, so then all you're doing is you're finding the minimum and so forth. And then it might say, where does the bridge attach to the, the log or something that's laying across the river. Okay, so you could say, oh, it attaches there, and those are the zeros again. Okay, so just kind of try to make the connection between all those words that you've been learning, and then now that we're looking at some real life problems here, so when they just say max height, it's the same as maximum. If they say the lowest point, it's a minimum, still the vertex. And then it just depends on what's going on with the straight horizon here. So if things are being connected to there or landing there on the ground, then you're looking at zeros and so forth, okay? All right, so go and practice some of the worksheet questions there and then try the checkpoint.